Good morning, all of you. Welcome to Sri Jayendra Rank Zone. So far, we have completed explanation part of 16th group elements. Now, we are going to do questions based on 15th as well as 16th group elements. All these questions are very important. So, these are the best questions we have selected already. So, we'll do all the questions right now. Then, we'll end up this session. And what we have to do at the end of the chapter, I'll do summary of the chapter. So, right now, let us start now. 16 group elements and 15 group together. We have seen questions now. So more questions we are going to do now because it's necessary to complete the objective point of view. Now, question number one: which of the following is not hydrolyzed? This is very important question. Which of the following is not hydrolyzed? So here the answer they have given. The options they have given: PF3, that is phosphorus trifluoride. Next they have given NF3, that is nitrogen trifluoride, antimony trifluoride, and arsenic trifluoride. So the answer is here NF3, because since nitrogen as well as both nitrogen and fluorine do not contain d electrons. Both nitrogen and fluorine do not contain d electrons. Hence, they are not readily hydrolyzed. Since both nitrogen and fluorine do not contain d electrons. So phosphorus contains d electrons, but fluorine does not contain. Antimony contains d electrons and arsenic contains d electrons. That's why they can be readily hydrolyzed, but NF3 cannot be hydrolyzed because both nitrogen and fluorine do not contain d electrons. Hence, it is not readily hydrolyzed. I hope it is clear. So let us see the answer now. So option B. So answer is B. So NF3 cannot be readily hydrolyzed because it does not contain both nitrogen and fluorine does not contain any d electrons. Hence, it is not hydrolyzed easily. I hope it is clear. Next question. So please note down the reasoning also. Reasoning is more important in inorganic chemistry. If you know the reasoning, easily you can solve the questions. You can remember the concept nicely. So for each and every question, I'll try to write the reasoning part. Next question. When tin is treated with concentrated nitric acid, what happens? It is converted into stannous nitrate, it is converted into stannic nitrate, it is converted into metastannic acid, and it becomes passive. So, since concentrated nitric acid is reactive and it is more acidic in nature, so tin is converted into metastannic acid. So, it is converted into metastannic acid. So, here I try to write the equation right down. Just note down, please. So, the reaction of tin tin with the nitric acid, with concentrated nitric acid. So you can just see here, it will form metastannic acid. The reaction is, please note down the reaction. Tin plus 4 molecules of HNO3, it forms H2O plus H2SNO3. This reaction is very important. That's why it is forming different compound. Plus 4 more. So as you already know, whenever you take concentrated nitric acid, the byproduct is nitrogen dioxide. That is reddish brownish gas. So reddish brown color gas, it is nothing but concentrated nitric acid. So it's very important. So I hope you understood. So this is the reaction. Please note down in your classwork. When tin is treated with concentrated nitric acid, it is converted into metastannic acid. The formula of metastannic acid is H2SNO3. H2SNO3 is called metastannic acid. I hope it is clear. Next question. So I'm trying to write everything. Which of the following is the correct increasing order of hydrolysis? So in groups, if you see the questions, the group comparisons will be there between 13th group, 14th group, second group, third group, etc. So not only they will not give only particular to one group, they will give different groups also. So which of the following is the correct order of increasing of hydrolysis? So first option, carbon tetrachloride, MgCl2, AlCl3, SaCl4, and PCl5. Since already we know for hydrolysis we should require at least d electrons. So which is containing more d electrons here? Phosphorus, because the atomic number of phosphorus is 15, silicon is 14. So first phosphorus, then silicon, then aluminum, then magnesium, then carbon. So answer is A option A. So for hydrolysis, to get readily for hydrolysis, please note down this sentence. For hydrolysis, availability of d electron is important. Availability of d electron is necessary. So carbon has no d electron, magnesium has no empty d orbitals, whereas aluminum has d orbitals, silicon has, and phosphorus has. These three has empty d orbitals. Hence, their hydrolysis power is more when compared to magnesium and carbon. So, as these three are having empty d orbitals, so they have more hydrolysis power when compared to carbon tetrachloride and magnesium chloride. I hope it is clear. So, please note down the sentence. For inorganic chemistry, whenever you are solving inorganic chemistry part in the competitive books, please write the reason. If you write the reason, it is more useful because your concept will be developed. So here itself, I have seen two questions we have seen. That is, availability of d electron is necessary for hydrolysis. So that's why either empty d orbital or d electron. So this is the answer. I hope it is clear. So for every question, try to write the reason. Then it will be easy for you, which is where it is necessary. Next, pyrophosphoric acid. So whether it is pyrophosphoric acid is monobasic or dibasic or tribasic. So first you should know the pyrophosphoric acid formula. So pyrophosphoric acid formula, if you take, then you'll get the structure. So automatically you'll get. So the formula of pyrophosphoric acid is, first you should know the formula, that is H4P2O7. And how many OH bonds are present between two carbon and two phosphorus? Because it contains two phosphorus, the structure is like this. So after that, you should know the structure. Then it will be easy for us to write the answer. So POH, then the two phosphorus are connected with oxygen, and this oxygen again, this phosphorus containing again one O and here one OH. So this is nothing but it is pyrophosphoric acid. This is the formula of pyrophosphoric acid, and this side it is OH, this side also it is OH. So since it contains single bond, one, two, three, four OH bonds. How many OH bonds? Four OH bonds. So this is also OH. I write it clearly. Please note it down. Since it contains four OH bonds, so it contains four OH bonds, one, two, three, and four. So since it contains four OH bonds, it is tetrabasic. So answer is C. Answer is what? C. So always write the answer clearly. So this is tetrabasic. Pyrophosphoric acid is tetrabasic because it has four OH bonds. For each phosphorus, two OH bonds are there. Since two phosphorus are there, so it has four OH bonds. So hence it is the tetrabasic. I hope it is clear. Please note down the structure also. Already we have seen given the slides for structures. So if you are thorough with the structures, easily you'll get the answer. Next, sodium nitrite. So this is NaNO2. Sodium nitrite. Nitrate is NaNO3. So sodium nitrite gives colored fumes on treatment with dilute acids. So what is the color? So on reaction with dilute acids, it gives on reaction with the dilute acids. So sodium nitrate on reaction with dilute acids gives colored fumes. So what is the color of the fumes is? So sodium nitrate. So it is reddish brown or reddish brown. None of these. Due to the formation of NaNO2. So it is here. Whenever sodium nitrate is there, NaNO2 is formed. So NO2 is formed. That is reddish brown color gas is formed. So answer is C. Answer is what? C. So NaNO2 plus HCl gives us NaCl plus NaNO2. Any acid, a dilute acid we take, NaNO2 plus HCl, it gives rise to NaCl plus NO2 plus H2O. So balancing you can do later on. So just giving an idea. So it forms reddish brown colored gas. So with the dilute acids only, not with concentrated acids. I hope it is clear. So next question, question number 6. When sodium nitrate, this is called sodium, the previous one is called sodium nitrite. Now this is sodium nitrate, is heated with ammonium sulfate. So when sodium nitrate is heated with ammonium sulfate, is heated with ammonium sulfate, it forms what? Ammonium sulfate. A colorless gas and a residue is obtained. The color of residue is. So when sodium sulfate is treated with ammonium sulfate, it produces sodium sulfate. So sodium nitrate is treated with ammonium sulfate. It produces what? Sodium sulfate, dinitrogen monoxide, and water. So the color of the residue is, white color because due to the formation of sodium sulfate. So sodium sulfate, I'm writing the equation, please note it down. Sodium nitrate on reaction with ammonium sulfate, NH4 taken twice, SO4, it forms sodium sulfate, Na2SO4 plus nitrous oxide, that is N2O, nitrous acid, nitrous oxide plus H2O. So this is the reaction, and the color of residue is white color because sodium sulfate is left over. It is not precipitate, it is residue. Residue means not left over, it is present in the container. So residue is white color because due to the formation of sodium sulfate. So answer is D. I hope it is clear. Please note down the answer. Next question. The strongest reducing agent among the following is. Strongest reducing agent means it should be more metallic in nature. The strongest reducing agent among the following is usually non-metallic oxides are SDK nature. So they are not reducing agent, they are oxidizing agents. So the strongest reducing agent among the following is H2PO2 minus because the non-metal in its lower oxygen state is a reducing agent. So answer is D, H2PO2 minus. Let us see the answer now. So it is H2PO2 minus. The strongest reducing agent among the following is H2PO2 minus because the metal is in the lower oxygen state. Wherever the metal is lower oxygen state, it is. If the metal is in higher oxygen state, it is oxidizing nature. And if the non-metal, sorry, here the non-metal is in lower oxidation state. Lower oxidation state. So it is readily losing the electron because H2PO2 minus can change into HPO3, HPO3 also. So hence non-metal is lower oxidation state is reducing in nature. In all other cases, phosphorus is having higher oxidation state. So and in this the phosphorus oxidation state is lower oxygen state, hence it is more reducing in nature. I hope it is clear. Next question, question number 8. Which of the following is a correct order of bond strength? Since already you know for nitrogen molecule, so it has 1s2, 2s2, 2p6. It has half filled and completely filled, half filled as well as completely filled. Completely filled, that is half filled in sense of p, and completely filled in sense of s orbitals. So what is the correct order of bond strength? And also we know the bond order and bond strength. Let us see now the answer here. So answer is C. So nitrogen greater than N2 plus greater than N2 minus. So since bond strength is proportional to bond order, 1 by bond order, inverse proportional to bond order. So the answer is N2 greater than N2 plus N2 minus. This is the bond strength order because nitrogen is having triple bond N. So it is more strongest. So it's very difficult to remove the electron from this or to break the bond. Actually, not to remove the electron, to break the bond. So answer is N2 greater than N2 plus. Why? Because it is 1 electron less, and N2 minus, it is more than 1 electron. So automatically the answer is third option. I hope it is clear. Question number 9. Concentrated nitric acid reacts with iodine to form. Just nitric acid is a good oxidizing agent. It converts iodine to hydrogen iodate. That is answer C. So nitric acid reacts with iodine to form hydrogen iodate. That is HiO3. HiO3. It's a good reducing agent. Sorry here. HiO3. Iodine changes to HiO3. So next question. The yellow color often shown by nitric acid may be removed. The yellow color, often shown by nitric acid, can be removed by adding a little bit of tin, boiling the acid, passing ammonia through the acid in cold, and bubbling dry air to the warm acid. So answer is bubbling dry air. So the yellow color of nitric acid can be removed by bubbling dry air to the warm acid so that yellow color of nitric acid can be removed. So this is theoretical question. So all these questions are very important. You'll find in different objective books the best questions I have selected, and I'm doing more questions on this. That's why. So please do these questions. Almost from these two chapters, we are going to do around 70 to 100 questions. So that's why these questions are most important. So please note it down. So the yellow color often shown by nitric acid may be removed by adding by bubbling dry air to warm acid. Next question. What is the name of the compound containing nitrogen, hydrogen, oxygen, which on heating gives laughing gas? So it is hydroxylamine, ammonium nitrate, ammonium nitrite, none of this. So to my knowledge, it is ammonium nitrate because ammonium nitrate gives N2O. Ammonium nitrate gives N2O. You can write on heating gives laughing gas. So on heating, ammonium nitrate on heating gives, I can write the equation now. Ammonium nitrate, ammonium nitrate on heating. So you can write the equation NH4NO3, ammonium nitrate, the formula of NH4NO3, ammonium nitrate on heating gives rise to nitrous oxide N2O plus 2 moles of water. It's very simple reaction. So nitrous oxide. So this is the answer is ammonium nitrate, and delta H is negative in this case. In this case, delta H is negative because it's an exothermic reaction. I hope it is clear. Next question. Question number 12. Which one is not an acid salt? Acid salt means they should have contain at least one hydrogen atom. So which is not acid salt is nothing but option A, because NaH2PO2 it is completely satisfying the valency, whereas NaH2PO4 is not satisfying the valency, and NaH2PO3 is also not satisfying the valency. Only NaH2PO2, that is sodium dihydrogen PO2, is an acid, is not an acid salt. The remaining two are acid salts. Acid salts means the salt which contains in the acid hydrogen should be there. So that's why answer is A. Next, question number 13. In the manufacture of safety matches, this question I have discussed already in the first lecture. In the manufacture, actually I will not discuss the question, I have discussed the concept. So in the manufacture of safety matches, we use what? White phosphorus, red phosphorus, black phosphorus, selenium. So white phosphorus, already we know it is more reactive, but it is not used in matchboxes, because in matchbox we have red color phosphorus will be used because it catches fire. So answer is red phosphorus. So option B. Option B. So in matchboxes, safety matches, that's the matchbox, we use red phosphorus. For that, that red phosphorus is burnt against. So if you light it, it will burn. It will catch fire. That is called cheminoluminescence. Cheminoluminescence, and that fire is used. I hope it's clear. Next question. Phosphine is produced by adding water to. Phosphine is produced by adding water to calcium carbide, calcium phosphide, and HPO3. This reaction also we have discussed. So answer is, what is the answer you can expect now? So phosphine can be produced by adding water to calcium carbide and HPO3 and Ca3P2 and P4. And where we have come this discussion, I'll tell you right now, please note it down. So when calcium carbide is added to water, it forms acetylene gas. When calcium carbide is added to water, it forms acetylene gas, that is C2H2 plus calcium hydroxide. There are only two options which may be doubtful, and this for this when you add with water, it forms phosphine gas, phosphine gas. And these things they use in Holmes signal. When this acetylene and phosphine gas is thrown, a mixture of this calcium carbonate and calcium phosphate along with water is thrown into the sea, it becomes Holmes signal. Holmes signal. This we have discussed already in the class. So please note it down. So when this acetylene gas and phosphine gas, that is the mixture, is thrown into the sea water, then what happens? It catches fire. It catches fire due to because acetylene will give you the fire, and phosphine and HPO3 will give you the light. So due to which fire and light will come, and due to which what happens? It forms Holmes signal. It is called as Holmes signal. It is used in sea. It is used in sea by ship drivers, that is captains. I hope it is clear. Next question, question number 15. Lead nitrate on heating gives lead nitrate. Lead nitrate on strong heating gives. It's a residue of lead oxide because lead nitrate on heating gives lead oxide plus nitrogen dioxide gas. So lead nitrate on heating gives lead oxide plus nitrogen dioxide gas, 2 moles of nitrogen dioxide. So lead nitrate, this is the equation. I hope it is clear. Next question. Ammonium nitrate is formed when? What happens when zinc is treated with dilute nitric acid? So when zinc is treated with dilute nitric acid, zinc plus dilute nitric acid will give you zinc and dilute HNO3. So it will give what? So zinc and dilute HNO3 will give. So you can see each and everything. So zinc on reaction with dilute nitric acid, it forms the this brown nitrogen dioxide gas is produced. So along with zinc nitrate. So with dilute nitric acid, it gives nitric oxide. So zinc gives, along with zinc nitrate, along with nitric oxide gas. Similarly, iron nitrate, along with nitric acid, tin nitrate, along with nitric acid. And the answer for this, from this nitric oxide on reaction with ammonia. So if you take nitric oxide on reaction with ammonia, it forms ammonium nitrate. Nitric oxide plus ammonia, NO and ammonia. It forms nitric oxide, ammonium nitrate. So the answer for this is D, all. From all these things, we'll be getting ammonium nitrate because zinc plus dilute nitric acid will form nitric oxide, that is NO. This NO on reaction with ammonia, it forms ammonium nitrate, NH4NO3, along with nitric acid. Further, ammonia, it forms nitric ammonium nitrate. The formula of ammonium nitrate is NH4NO3, NH4NO3. So from all these things, we can get ammonium nitrate. Answer is all. So please complete these equations in your classworks. It will be useful for the examination, competitive exams. Next, a diatomic gas will be obtained when heated. So what happens when diatomic gas is obtained? When potassium nitrate is treated with potassium. Potassium nitrate is treated with potassium. It forms potassium nitrate. I've just tried the equation. Please note down. Potassium nitrate with potassium gives. So potassium nitrate with potassium gives. It forms oxygen gas. It forms. So KNO3 plus K gives rise to KNO2 plus O2. So KNO2 plus O2, that is diatomic gas. So only answer is A, because for this if you give, it will give only nitric oxide. So answer is KNO3 plus K gives rise to oxygen gas. So diatomic gas, answer is A. I hope it is clear. Next question. Just I'll do it, clear the line. Which of the following is correct about the products of the reaction? NO2 plus NOH gives rise to A and B plus H2. I just told you The reactions they'll give you, even the reactions also they'll give incomplete format. You have to complete it. So the NO2 plus NaOH and NaOH will give you the reaction NO2 and NaOH reaction. It is the alkali NaOH to form salt and water. So here the Na2 and NaOH forms. I'm writing the complete equation right now. Just please guess it. I'm giving time so that you can write equation easily. So the answer is 2NO2 plus 2NaOH gives rise to NaNO2 sodium nitrite plus sodium nitrate. Very, very important. Sodium nitrate plus sodium nitrate plus water. So answer is sodium nitrate and sodium nitrate. So both A and B are heating with sodium will form nitrogen gas. Both A and B are heating with zinc and the sodium hydroxide produce ammonia. So they are not only completing this equation. First, you should know what is A and what is B. This is A and this is B. So sodium nitrite on heating with sodium forms nitrogen. Let us check now. Sodium nitrate on heating with sodium. Writing the equation now, please note down. Sodium nitrate, NaNO2 on heating with sodium. Please note it down. On heating with sodium gives oxygen. It is not sodium nitrate. Sodium nitrate on heating with sodium decomposes to form sodium nitrate and oxygen gas. So here they are giving nitrogen gas. So it is not correct. So answer for this is C option. That is both are correct. So it can form nitrogen. Sodium nitrate. No, actually I have taken sodium nitrate. So sodium nitrite on heating with sodium hydroxide form nitrogen gas, and even with sodium nitrate also it forms sodium nitrogen gas. So answer is C, both are correct. Solid PCl4 exists as, since already we know it exists as, it is ionic in nature. As I told you, solid PCl4 exists as, it is ionic in nature, because even though it is non-metal and non-metal combination, but still it is ionic in nature due to the presence of PCl4 plus and PCl6 minus. So answer is B. This topic we have discussed in the class itself, the session. So it is ionic in nature because it's forming ions. So it is ionic in nature. Solid PCl5 is ionic in nature, and liquid and gaseous PCl5 is not ionic in nature, it is covalent in nature. And in solid PCl5 it exists as PCl4 plus and PCl6 minus. These are highlighted also already. Even in the question also we discussed. So I hope it is clear. Next question. How many PO bonds and how many lone pairs respectively are present in P4O6 molecule? Very, very important. This question is very, very important. So this type of questions are expected. So that's why you should be thorough with all the structures. So this is the structure of P4O6 structure. So if you take P4O6 structure, you'll get the answer. So I'm writing the P4O6 structure. It is a phosphorus trioxide is a chemical compound with the formula, molecular formula P4O6. Now I'm drawing the structure of P4O6. Please note it down. So the P4O6 structure can be like this. It's a huge structure. I will try to draw it here itself. So P4O6. So phosphorus, oxygen, phosphorus, again oxygen, again phosphorus, again oxygen, again phosphorus. So, and here P, this is oxygen again, this is again P, this is again oxygen, this is again P. So this is P4O6, and this phosphorus is again with oxygen like this. So this is P4, 1, 2, 3, 4 phosphorus, oxygen 1, 2, 3, 4, 5, 6, total 6 oxygens. And here 1, 2, 3, 4, 5, 6 oxygens. So please note it down. And each phosphorus is having 2 lone pairs, so 1 lone pair. Each phosphorus is having 1 lone pair because the phosphorus is linked with 3 oxygens. Each phosphorus is linking with 3 oxygens. You can see here, first phosphorus is linking with this oxygen, and this oxygen. Second phosphorus is linking with this oxygen, and this oxygen. So each phosphorus, since each phosphorus is linked to three oxygen atoms. Three oxygen atoms by single bond, by single covalent bond. So it has one lone pair, single covalent bond. So it has each phosphorus has one lone pair, one lone pair. So with this you can try to understand. So how many, they're asking how many lone pairs and how many PO bonds. So it is nothing but how many PO bonds? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is nothing but how many PO bonds it has. So we can easily guess it. How many lone pairs we have? 1, 2, 3, sorry, 1, 2, 3, 4 lone pairs. So 4 lone pairs, only first option. So answer is A. Answer is what? A. Please note down in your classwork. So it is 12 and 16. They are asking lone pairs respectively. Lone pairs means here, this might be mistaken. It is actually A because it has only 4 lone pairs. So please check the answer. It is answer is A because this is the structure of phosphorus. So it has 12 PO bonds and 12 PO bonds and 4 lone pairs. So please note it down. So each phosphorus is having one lone pair. So it is 4 lone pairs and 4 lone pairs because they are asking lone pairs, not number of electrons. So even if they ask number of electrons also, it is wrong. So answer is only 12 and 4. So please note it down. So answer is A. This is the structure of each phosphorus is linked to 3 oxygen atoms. You can see here, this phosphorus is linked to this oxygen atom and this side one oxygen atom and inside one oxygen atom. So like that each phosphorus is linked to 3 oxygen atoms separately I'm writing. So like this 4 phosphorus, and here already we know the valence electrons, number of valence electrons on phosphorus is 5. So it has one lone pair. So each phosphorus has one lone pair. So this is one lone pair, 2 lone pairs, 3 lone pairs, and 4 lone pairs. So this also will have lone pairs. So it has 4 lone pairs. So 100% the answer is 12 and 4. It is not 12 and 16. So please note it down. I hope it is clear. Next question. Which of the following metals, iron, zinc, lead, silver, and platinum, do not give metal nitrate on treated with concentrated nitric acid? So already we have seen metal nitrate. Metal nitrate means zinc nitrate, iron nitrate, lead nitrate, silver nitrate, and platinum nitrate. Do not give metal nitrate on treatment with concentrated nitric acid. So most probably it is iron and platinum because we have not seen iron. Zinc nitrate we know, lead nitrate we know, silver nitrate we know, but we don't have platinum nitrate and iron nitrate because they will not form with, they are passive with concentrated nitric acid. I hope it is clear. Next, which of the following halides is most acidic? Most acidic halides. So which of the following halides is most acidic? So already we know halogens, nothing, non-metallic halides are acidic in nature, and out of this, which is most acidic in nature, we are going to discuss now. So answer is PCl3 because the oxygen state of phosphorus is +3, and bismuth chloride is basic in nature. It is not acidic. Antimony is also metalloid. Carbon is a non-metal, but it is Cl4. So the oxygen state is low. So 100% it is PCl3 because PCl3 when dissolved in water it forms H3PO4. So I hope it is clear. Next question. When H2S gas is passed through acidified potassium, when H2S gas is passed through acidified potassium dichromate solution, the solution turns. When H2S gas is passed through, that's why this is used for titration also, as I told you. It turns what? It turns green color solution. When H2S gas is passed through acidified potassium dichromate solution, it turns, just write the equation here, just please note it down. H2S gas on reaction with potassium disulfide, H2S gas. I'm dictating you, please write down H2S gas on reaction with potassium dichromate. With K2Cr2O7. Potassium dichromate is what? K2Cr2O7. So what happens here? K2Cr2O7, writing the equation, please note it down. K2Cr2O7 plus hydrogen sulfide gas combines together to form chromium hydroxide, 2 moles of chromium hydroxide, that is CrOH taken thrice, plus 3 sulfur, plus 3 moles of KHS, that is potassium hydrogen sulfide, plus water. This reaction is very rare and unique, so please note it down in your classwork. So it forms this. So potassium dichromate, sulfur, plus the potassium green color, it is due to the formation of. So potassium dichromate reacts with hydrogen sulfide to produce ammonium chromium 3 hydroxide, sulfur, potassium, and hydrogen. So it is the green color is due to the formation of sulfur. Green color is due to the formation of sulfur. I hope it is clear. So this is the reaction. Please note it down. Next question. Which one of the following is purely reducing agent? Which one of the following is purely reducing agent? Hydrogen sulfide, hydrogen peroxide, ozone, sulfur dioxide. Already we know ozone is an oxidizing agent. Hydrogen peroxide, hydrogen sulfide, and sulfur dioxide we have to see. So the answer is A. Hydrogen sulfide is a reducing agent because it reduces potassium dichromate to sulfur. So that's why it is a good reducing agent, hydrogen sulfide. So hydrogen sulfide is a purely reducing agent, remaining all are oxidizing agents. And hydrogen peroxide acts as both oxidizing agent as well as reducing agent. But only oxidizing reducing agent they are, so it is only hydrogen sulfide because this is both oxidizing as well as reducing agent. Both oxidizing and reducing agent. Both oxidizing agents as well as reducing agents. So it is not the right answer. And reducing agent. Ozone is purely oxidizing agent. Sulfur dioxide also is oxidizing agent. So answer is this is also O dot A, that is oxidizing agent. So answer is A. I hope it is clear. Next question, question number 25. So we are trying to do maximum possibility questions. The element which evolves two gases with concentrated sulfuric acid is on reaction with concentrated sulfuric acid, which element will give two gases? That is option B, that is carbon. So carbon on reaction, the element which allows two gases with concentrated sulfuric acid is. So we can see here, please note down, carbon on reaction with carbon with concentrated sulfuric acid, it forms. So I'm writing the equation, please note it down. So when carbon combines sulfuric acid, carbon plus concentrated sulfuric acid, it is very important. So only concentrated, it forms carbon dioxide gas plus 2 moles of sulfur dioxide plus 2H2O. So it is giving two gases, evolves two gases. That is, one is carbon dioxide and there is sulfur dioxide. So the element which evolves two gases with concentrated sulfuric acid is carbon. It is, the answer is carbon dioxide and sulfur dioxide. So please note down this reaction in your classwork. So all the questions we are trying to write the reasoning also. So please note it down and do it. Next question. Which one of the following on heating will give mixture of sulfur dioxide and sulfur dioxide? So sulfur dioxide and sulfur dioxide, it is FeSO4. So FeSO4 on heating gives, it is a mixture of, since FeSO4, that is iron sulfate, FeSO4 on heating gives a mixture of sulfur dioxide as well as sulfur dioxide. Very, very important reaction. This is the decomposition reaction of FeSO4. So ferrous sulfate, I'm writing the equation, please note it down. Ferrous sulfate on heating, so 2 moles of ferrous sulfate because it is Fe2O3 on heating gives decomposed to form ferric oxide, that is Fe2O3 plus sulfur dioxide plus sulfur dioxide. So this is a mixture of sulfur dioxide and sulfur dioxide. So Fe2O3 on heating gives FeSO4 on heating gives Fe2O3 plus sulfur dioxide plus sulfur dioxide. I hope it is clear. Next question. H2S is passed through potassium permanganate solution. We get potassium sulfate, sulfur, potassium sulfate, manganese sulfate. So potassium sulfate, this already we have seen this H2SO4 potassium permanganate. Here this is sulfide is formed because H2S is a good oxidizing agent. Sorry, good reducing agent. So it forms sulfur. So it reduces hydrogen sulfide to sulfur. So this is called potassium permanganate reduces hydrogen sulfide to oxidizes hydrogen sulfide to sulfur and itself get reduced. So that's why here this is called answer is sulfur. This reaction same like potassium permanganate. This also we write here hydrogen sulfide gas on reaction with potassium permanganate. It forms manganese hydroxide along with sulfur plus KHS and so on. So same reaction you can see here plus H2O. So 5H2S we'll take into consideration. So 2 and 2 here. So 4 and 1 here, 5. So it is correct now. So this is the equation. Same for both potassium dichromate and potassium dichromate as well as potassium permanganate gives the same products. That is KHS, MnHS and sulfur plus water. It is also showing green color. Next question. When sulfur dioxide is passed through a solution of H2S in water, sulfuric acid is formed, a clear solution is formed, sulfur dioxide is reduced, no change is observed. So you can write here, the answer is sulfur dioxide is reduced. So sulfur dioxide is reduced to sulfur because hydrogen sulfide is a good reducing agent. So sulfur dioxide SO2 plus H2 and HCl and H2S. H2S reaction you can write. I'm writing the equation here, please note it down. So it forms H2O plus S because sulfur is formed. Sulfur dioxide is reduced to sulfur. So SO2 plus H2S gives rise to H2O plus sulfur. This is the product you can do balancing. I hope it is clear. So it forms H2O plus S. That's why hydrogen sulfide is a good reducing agent. Reducing agent. Next question. Concentrated sulfuric acid displaces hydrogen chloride from metal chloride because it is stronger than hydrochloric. HCl gas. HCl is a gas where sulfuric acid is a liquid. Sulfates are more soluble than chlorides and no change is observed. So answer is HCl is a gas while H2SO4 is a liquid. So HCl is a gas while H2SO4 is a liquid. That's why it can displace hydrogen chloride from metal chlorides. Which of the following turns lead acetate paper black? This is the test for hydrogen sulfate. Hydrogen sulfate, when you pass hydrogen sulfate gas to lead sulfate, it turns paper black because it forms sulfur again. So that is why the answer is hydrogen sulfide, option D. Next question. Mark the wrong statement. When sodium sulfide is added to sodium nitroprusside solution, this is very, very important. This is used for Lassane's test. You can see here, Lassane test. So what is this here? I'll write here. So it is called Lassane's test. This you will find in organic chemistry. So it is sodium prusside, sodium nitroprusside solution. Beautiful violet color is produced. A complex ion is formed. A complex ion is formed. So this is nothing but due to the formation of reddish brown. That is also called as brown ring test. Also, you can say uh, iron cyanide hexapentasino nitric oxide sulfur is formed. This is called sodium nitroprusside solution is added to sodium nitroprusside. When sodium sulfide is added to sodium nitroprusside solution, it forms a complex form. It is the answer. So this is used in Lassane's test. I hope it is clear. Then it's finally converted into this. So you can refer Lassane's test. Refer Lassane test in 11th class. Next question. When hydrogen sulfide gas is passed through nitric acid solution, the product formed is just simple. It is colloidal sulfur because whenever hydrogen sulfide is passed through nitric acid solution, hydrogen sulfide is getting oxidized because it is a good reducing agent. So automatically it will give sulfur as byproduct. So answer is colloidal sulfur. Colloidal sulfur. I hope it is clear. Next. Mark the compound which gives carbon with concentrated sulfuric acid. Already we have seen this. So carbon with concentrated sulfuric acid The compound which gives carbon with concentrated sulfuric acid, formic acid, succinic acid, oxalic acid, sugar. So answer is sugar. So when sugar is treated with already we have seen this reaction because when sugar is treated with when sugar is passed to C12H12O11, it is called sugar. When sugar is treated with concentrated sulfuric acid, it gives black color char due to the formation of carbon. Black char. A char is formed, that is due to the formation of carbon, black color. So that is called, it is nothing but this test already we have seen. So this is nothing but the compound which gives carbon with concentrated sulfuric acid is sugar because it forms carbon black. It forms char on the sugar, black color char. So it is nothing but due to the formation of carbon. So all these questions are very important. Next, about sulfuric acid, which of the following statement is incorrect? It is acting as a reducing agent, it acts as an oxidizing agent, it acts as dehydrating agent, it is highly viscous. So answer is it acts as a reducing agent because sulfuric acid is a good oxidizing agent. We already know it is a good dehydrating agent. Already we have discussed so many times. It is highly viscous. And only the option is incorrect is option A. It is not a good reducing agent. It is an oxidizing agent. Next question. Sulfur dioxide is obtained by the action of dilute sulfuric acid on. Sulfur dioxide is obtained by the action of dilute sulfuric acid on copper turning, sodium sulfate, sodium sulfide, and sodium sulfide. It is sodium sulfide. Sodium sulfide on reaction with sodium sulfide formula is Na2SO3. On reaction with dilute H2SO4, it forms sulfur dioxide gas. So answer is C. With sodium sulfate, it will not form. Copper turnings, it form copper sulfate. And sodium sulfide. Sodium sulfide is different. Sodium sulfide is different. Sodium sulfide is Na2S. It cannot form. So this is answer is only C. I hope it is clear. Next question. So with this, we have completed all the questions. So please go to 15th group and 16th group all the slides and prepare your notes. It is very, very important. And we have discussed almost 70 to 80 questions for the entire two chapters, almost 80 to 100 questions. So please follow this. And these questions are most important to my best of my knowledge. So remaining we'll do now this is the end of 15th group and 16th group elements chapter. So next we'll do 17th group and 18th group. I hope it is clear. So please follow strictly the slides and do compulsory after finishing the chapter. You please work out more questions from the competitive books which you had with you, either Jayendra material or any other material like any other material. If you work out more number of questions, you will be knowing the concept more easily. And don't forget to work out more number of questions. And also for this, as this topic is inorganic chemistry, simply write the reason as I wrote the reasons for each and every question. Like that, you also write the reason in your classwork or in your objective book. I hope it is clear. Thank you all.